My name's Rhett Jesse, and today we're going to talk about the Metrix digital proximity system. Today's experiment, we're going to talk about changing from an MX8030 probe and cable system to a competitor's probe and cable system to see how the digital proximity system works. What's nice about the digital proximity system, whether it's an MX2034 transmitter or an MX2033 driver, is we can configure it for the probe and cable that we need it to work with. We already shown that it works with a Metrix system, so that's not a problem. Let's see if it works with the competitor's probe and cable and see if we can get a nice linear characteristic, well within the 190 to 210 millivolts per mil required from API. So let's go ahead and do that demonstration. I'm going to go ahead and change out the probe and cable. So I'm going to take the cable off the digital proximity system, and then I'll go ahead and remove the probe from the static calibrator. Then I'll go ahead and put in the competitor's equipment. Go ahead and connect it to the digital proximity system. And go ahead and insert the probe. Make sure I'm at 0. Make sure it's nicely clamped in there. Okay, it looks good. All right, we're at 0. And what we'll do is we're going to change the configuration in our digital proximity system software. So we'll go to change configuration, and we're going to change the probe series from MX8030 to BN3300XL. I'll look for that. BN3300XL, I find that, and it's a 8mm probe with a 5-meter cable, and we'll set the scale range, because we're working with the transmitter, to 10 to 90. Then we'll send that configuration. Okay, now the digital proximity system is set for this probe and cable system, and we're going to check for its linearity. So we're going to use the tuning and verification tab to do that. So we'll let the configuration go through, and then we'll go to tuning and verification. And we'll do what the tuning and verification says. We'll do the offset and the 1 volt tests, and then we'll do the verification to see if we have linearity. If we don't, we'll do a custom calibration. Well, first I'll do offset. Offset gets the top end of our curve when we look at how we look at the scale factor on our plot. And we'll say, is the probe in the open position? It is. There's more than a ½ an inch of gap there, which is what we need, over 12 millimeters. Make sure we don't have any influence, and we'll say yes. And now we'll record that data. Then we'll have me move the dial micrometer to 10 mils gap, and then we'll get it at 1 volt. Okay, offset is complete. Now we'll go to 10 mils at 1 volt. And what this does, it just helps with the linearization of the system. So we'll capture the voltage at 10 mils. It's 0.999, very close to 1, which is good. And then we'll do it in 10 mil increments. We'll record voltages and just see how linear the system is. And if it's not perfectly linear, we'll go ahead and do a custom calibration, but we'll see how it does. All right, that was our last point, and if you look at the incremental scale factor, it's between 190 and 210 millivolts per mil, and that's really excellent for a proximity probe system, and it shows that the Metrix digital proximity system works with a competitive probe and cable. Thank you very much.